think that as I was going to say that one of the challenges I think for this presentation is realizing that we have a pretty varied group, people who know seismic data inside out, and those that are not familiar with it. And as exciting it is to me to talk about it, I think it will be important to really minimize quantification about seismic data. And I have to say that's a challenge for me. So this slide is to show that, to keep my mind on the ball, or keep my eyes on the ball, is that we are set in our ways, and we really want to know how much work is needed to get to the other side, right? So, and that seems to be the theme, I think, of our last few data help session meetings. So what are the types of geophysical data? Well, as I was mentioning, that seismic data are the one that I'm most comfortable with, and they are made out of earthquake data, refraction, reflection data, earthquake tomography, and not in other, let's say, subcategories. And then there's followed by potential fields data, which are electromagnetic, and gravity. And as you can tell, there's quite a bit that goes into these groups. And kind of most recently, I've been dealing with airborne electromagnetic data. And so I would be excited to talk about that if we have any time left. And and then the rest is borehole data, remote sensing, and maybe other types of data that are borderline geomorphology and not, strictly speaking, geophysical data. So it's like for mineral composition, that's what XRF is used for. Let's see what's next. So I think the first thing that we all do is, like I said, these problems have been around for a while, is how to deal with geophysical data, how to deal with seismic data. So let's see what other agencies are doing. So as far as seismic data, strictly seismic data, so earthquake seismology data, there's not a whole lot of leeway left for us. This is the go-to for earthquake seismic data, and we should completely follow the IRIS guidelines. So IRIS, well, I'm not going to go into what this particular agency does, but it's about collecting data, seismic data, and making them available to the world. So the agency relies on the seed format, and that's, as the sentence says, it's pretty much kind of set in stone format to exchange seismological data. So if you have earthquake data, you already know this. And so again, there's maybe no need to spend a whole lot of time on this slide. So this is what we need to follow. And that's pretty clear. So we can discuss the details about the format maybe at some other time. So what about non-earthquake data? So, and that's the data that you can collect, and I'll touch on that you can collect as refraction data, your own reflection data. So it's non-earthquake data. So data that have an active source. So, and a lot has been done in that respect. And so our go-to would be this particular Python framework for processing seismological data. What they're promising is that they can deal with all kinds of seismic data formats. And my kind of guideline is, where will I draw the line? Like how far I'll go to, how much work I need to do to meet a fair motto, right? Or mission statement in a way. So how much work I need to do? I think if I can provide my data in one of these formats and provide a link to the Python library, I think that covers a lot of ground. I think that then anyone can view and use the data I have. So this is a pretty well respected and received Python library framework to deal with seismic data. What about potential fields? That was all the electromagnetic data that are created using electromagnetic surveys. Well, the situation here is a little bit more complicated. So, but a lot of people here that dealt with potential fields data will know that GeoSoft is a program package to go to. And now all these pieces of software have been acquired by, I think it's pronounced Sequent, I'm not 100% sure. So they bought a lot of tools and packages, software packages that seismologists and geophysicists have been using for a while, right? And all these tools have free viewers. And so that's another big step. And then later I can talk about what that really means. But as far as potential fields, these are the software packages to use. And again, they have free viewers so you can view the data. About data conversion, that's a different story. Okay, so what does the USGS does? USGS provides potential fields data, right? Let's say here we have gravity and oh, it is just gravity, but it was magnetics. So we can go down the list. So some of these files represent the same potential fields or the same type of map, let's say, but they come in different formats. And so this is what USGS is using and allowing you to download these data sets. So again, it's going to be really hard to escape this ARC info. There's also some XYZ text files. That's going to be just your XYZ and the value location, so you can recreate your maps yourself. And at the bottom of the list, you can see a GeoSoft grid file. So GeoSoft is a really widely used piece of software to deal with potential fields, and allows you to create. It does allow you to change from one format to another. I used this at some point in my career, but it's been a while, so I'm unfamiliar with all the new features that this package can do. Okay, so what about us? What does the Bedrock cluster do? What kind of data do we have, and how will we approach the mission statement, right? HydroShare mission statement. So this is, as far as seismic data, this is what we use. So it's Geometrics Geode. Without going into too many details, what it does, it collects active source seismic data or passive source seismic data. And it saves the data in these 3 data formats. And like I mentioned or show that Python framework easily deals with this and can create these different data formats in these data formats. So in a way, there's not a whole lot of new ground to cover here. So we have an acceptable data format that can create any other data format. What about, so we use surface resistivity. So, and this instrument produces text files. So again, that's pretty straightforward. There's not a lot to worry about a data format here. Then we use GPR antennas. And so the company that makes these instruments, it's called Sensors and Software. And we use 2 types. So these are 2 antennas, if you can see the bottom, but they are used differently. One is used as a car, car format, and the other one is as a tow. So, and this is the most proprietary type of data we use. And you have to have a paid piece of software, which is called Echo Project, that will open these files. However, once you open these files, you can convert them into two two type of files: a header file that looks like you can see here, and then a binary data file that is a .dt1 file that can be opened again by a multitude. Okay, multitude is maybe too much to say, but it can open with at least two programming languages, right? Python and R. And so, of course, it can be opened with MATLAB. And then I think MATLAB would be a good piece of conversation, is that this piece of software is not free, but it's widely used in academia, right? So I think that would be a good place to discuss where we should draw that line in the sand, what formats should be acceptable for sharing. Anyway, so this is what we deal with here. And yeah, so let's say that file that those antennas create, they end up in this proprietary .gpz format. So what else do we do? So we use a lot of non-instrument recorded data files. And this is one example. So for seismic refraction studies, we rely on nodes. So, and they're pretty self-explanatory, but I would encourage other groups that are not maybe providing these, so that they do. This is really critical. And again, without going into details, but all these things are, this is really useful to recreating the geometries and understanding what these .dat files are. So what are my kind of off-the-bat recommendations? Well, whatever you're using, there must be a free viewer for your data. If not, you just have to convert them into something else that has a free viewer. And then once you upload to your favorite data repository, you have to create the best is create a link to the conversion software. Providing little scripts to do the conversion is great, but everything's changing. And so providing at least a link to what you use, I think is ideal. And then again, what we already we were beating to death is that we need to describe everything we upload, but that's, yeah, we discussed that before. So I would like you to do some homework, and that is to send me examples of your geophysical data, especially those that I didn't cover and I don't have direct experience with. It's like nuclear resonance files or such, but I suspect they will be in text files. And then I think if I have this, especially for non-seismological data, I think that will help me create a more comprehensive best practices to create a better document. Okay, so this is what I have for now, and I'd like us to discuss this in more detail and maybe get people's opinions. Thanks.
Thanks, Ivan.
Yeah, hi, Jeff.
In the best practices document that Clara created in Google, I was just furiously typing away notes as you were going through your presentation. But Ivan, I'm hoping you also will share your presentation with us afterwards, because I probably did not spell everything correctly or capture everything that you said during the last few minutes. But that was a much more in-depth and helpful overview of geophysical data than I think I've ever had. So I definitely appreciate that. I'm interested in hearing from everybody else who's on the call today. Like, what Ivan is talking about here resonating? Are you collecting similar kinds of data? Are you facing similar kinds of challenges? Like, where are we at with everybody else?
Yeah, particularly people who deal with I guess you already said that, so geophysicists in the call.
So Sue, I think I remember the Drylands cluster saying they were collecting some geophysical data as well. Is any of this resonating with some of the things that are going on in the Drylands cluster?
Yeah, I think we're using a lot of the same kind of equipment and workflow that Ivan described here. Yeah, and they've been storing, our seismic data is all going, is that one? Yeah, the seismic stuff I think is on Iris, and the rest of it we have like ground penetrating radar and some other stuff like that. Right now they're just storing it in like a shared drive. And it has a lot of the accompanying metadata files that Ivan described, files and whatnot. I can pull up an example if you want.
If you have examples, I mean, I'd kind of be interested in seeing what some of this data actually looks like because I don't have much experience. I mean, the ultimate goal here is to arrive at a best practices document that basically says, if you're collecting that seismic data, send it to IRIS and follow these standards, which are the IRIS standards for seismic data, and everybody should be registering data sets shared in IRIS with the data submission portal so we know about them, and then we can point people to IRIS to find the stuff that you're sharing. For the other types of data, I think maybe we need a little bit more prescription there, because it didn't sound like, other than IRIS, there's really accepted repositories for a lot of this other kinds of stuff. So I think we just need a reasonable set of recommendations for where things can and should go to be shared. But the more we know about these data, the better off we are, because I know there are people like the urban cluster, they're also collecting geophysical data, and they couldn't be here today. Like Claire and John were in another meeting today, so they weren't able to be here. And I think they would just appreciate knowing, like, okay, for the types of data that they're collecting and that are similar to the ones that you all are collecting, what should they be doing so that we have as much standardization as possible. And Yvonne, in your presentation, I think you covered a good number of the elements that we have in this Google Doc. Now it's just a matter of sort of parsing them out into the right sections and getting a few words around them.
Yeah, Jeff. Thanks for doing that. It's on me. I need to work on that document. But yeah, the idea was to do this general presentation first, and then also for things to crystallize in my head. So because the actual document is what that matters. This presentation is fine, but yeah, that document is for the eternity. So it needs to be done with more brain power.
Ha, for the eternities, we should be so hopeful, right? So, Sue, your data is mostly ground penetrating radar and resistivity.
Yeah, and I just put a link to basically like our IRIS presence for for our seismic stuff at Jornada. Yeah. And right now, I don't actually have the software downloaded on my desktop to open a lot of these files, but we're just there's two groups. So it's Lynn Ma and Mark Engel, and to some extent too, the guys in Kimberly. So that would be Dave Huber and Dave Bjornberg. I think they have another guy that's helping them out with that. They're collecting that stuff and backing it up to a drive that we have here. And Ivan, you can probably have a better, so it's like a lot of ground penetrating radar. And there's just a number of different projects. Basically, I think they're transects. And so you have like a .dt1, the GPS file, and then the header file for each one of those lines that they do with the ground penetrating radar. It's kind of like a cart that they push.
Correct. So yeah, that's what we use. So maybe the upside of this is that there's only so many instruments and we all use them. So if I know there's 2 GPR systems, but that could be it. And the one we use currently, I have been familiar with that one. So it's a popular, it's a software, it's sensors and software is a big player in the field. So people will do the same data processing and the rest, we all do the same. So the only question is, okay, so what does the public want? Well, can they process the data in the same manner? Well, yes, because it won't, they're not going to get this exactly same amplitude. Let's say we do AGS, you know, auto gain control, AGC. We do AGC in Echo project. And we say that, let's say we upload our data to HydroShare, and we say, well, we applied AGC. And now, why don't you go home and do that in your MATLAB? Oh, wait a minute, you don't have MATLAB, right? Because you're public. Okay, you do that in your, you do it in R. And when they apply AGC, they will not get exactly the same results because they're going to use a different piece of software. But that's okay, because it says what we, you know, it's clearly open, it's clear what kind of processing we did, and they can reproduce that somewhere else. And I think the kind of line in sand should be, if you can do it in Python and equivalent, that's as much effort as we should do. Like that's, I think we're meeting the mission statement of our cluster, right? Of our, what am I looking for? Hub. I'm kind of yeah, blanking on the word, but so then they're meeting the objective, meeting the mission statement. I think that's where the line should be. So if you can open in Python or equivalent piece of software, then that's good. And process it, that's pretty good. I think we should be happy with that. I think we're meeting then the mission statement.
Yeah, our resistivity stuff is all stored as DAT files, so that seems like it's pretty straightforward. But if you have some suggestions on how to publish the GPR data in a little bit more open source format, that'd be great.
Yeah. So okay, that wouldn't be a problem. I think that would be good to do, and I don't mind playing with packages and see how they work. And the upside, unlike seismic data, GPR data don't get processed tremendously. I mean, this is a very qualitative statement. So seismic data, and if you want to process seismic data, yeah, you can use Seismic Unit, which is free, and really good luck if you are a, you know, Joe Plumber. Good luck learning how to use Seismic Units to process your data. So again, the tools are available, right? So it's pretty amazing. Like seismic. Well, I don't want to kind of beat the dead horse. So as far as seismic data, we are in good shape because there's so much out there that people can use to view and process the data. So as long as we list the steps we did and the geometry is clear, which is mostly in the headers, not necessarily. So that would be one requirement. Like you have to make sure that the geometry is reproducible from the headers. And that's, I mean,
maybe this is, sorry, go ahead.
No, that's yeah, good. So what can happen is, yeah, if you in your software in the acquisition, you do not define the geometry, and so your headers don't have it, well, then yes, you need to provide a way. One really low level step or way is people have observer nodes. So there's a spreadsheet telling you where the receivers were. That's horrible because then you have to do everything by hand. But that is a way to deal with seismic data. So, I mean, this is really all general, but in my mind,
yeah, so we have transects and we have grids. And all of it's in like a GPS, like a GIS, I should say. And then we just have like in sort of tabular format links to data set locations. And each one for the GPR, it's still in its proprietary format, but for the seismic, or sorry, for the resistivity stuff, it's all in DAT files. So,
right, yeah, but GPR also has, when you export, it's going to export a GPS file as well. So those two I show that are not GPS, but there's a GPS file too. So,
right, 'cause it's like
you
not
know,
GPS.
yeah, so again, I guess one of the things I need to write down is, I mean, how, speaking of the line in the sand, how far we should go in explaining how to reconstruct our processing. Providing scripts to do it, I think that's too much, but I could be along in that. Is I just listing the processing steps and providing all the files, that's plenty. So I think for the homework, I think that's important, and I would like to bring that up again, is that we try to think for our data sets, okay, how much work do we need to do to make them, to meet the mission statement? So how much work do we, so all of us individually, you know, and individually, how much work do we need to do? Just write down like a bullet itemized list. So, you know, we talked a lot about ArcGIS and so on, but if the USGS is expecting, like I showed the potential fields, they're expecting then people who download these data to be okay using GeoSoft and using ArcInfo. That could be then the line in sand, I think, for that, for GeoRef data. So now it's, you know, but Jeff needs to, you know, I guess make the decision on that.
Well,
Is that acceptable?
yeah, I mean,
Yeah.
I don't know that I'm going to make a decision there. I mean, I have some thoughts about this, and I think there's some principles that we can lay out in our best practices. We're never going to get 100% adherence to those principles, probably, but it shouldn't be because we have not laid the principles out. We should lay the principles out, invite people to follow the best practices, and try to do as well as we possibly can. The really prescriptive way of telling people, you know, thou shalt do this, and it's unacceptable if you don't do this, means that instead of getting people to share like 90% of the data, then you maybe get 50% of the data, because some people just throw up their hands and say, I'm just not going to do that, right? So
yes, yeah.
In terms of these checklists, like I think these are really good ideas to write down the bulleted lists of things that we recommend people do associated with these data sets. I think we should make recommendations about specific formats that people should be using. And if there are proprietary formats that are like, everyone in the community accepts this proprietary format and everybody knows they just have to buy a copy of this software and it's just what everybody does, like I don't think it's a smart thing to do to say, well, let's change that, because that's what the community has accepted and that's what the community is doing. And as long as it's well documented what you have done, what format you're using, what software you need to access the data, and the data are available, I think that meets the spirit of our requirements here. Now, if we have an option, like if it's 50-50 and you're like, well, we have a proprietary format, and on the other hand, we have this non-proprietary format, and no one is really clamoring to say one or the other, then I would pick the open format, because you know more people are going to be able to access it, and it's sort of a no-brainer in an open, fair context. But yeah, I think we have to be really cognizant of what the communities are doing. Number one, we want to make sure that the data are being shared, and number two, we want to make them as open, accessible, interoperable, and reusable as possible. And those last ones are the harder parts, right?
Okay, that makes sense. I think that the first group we should satisfy is, sounds stupid, but it's us and our peers. Because if the data, if we say that the proprietary format is not, or a proprietary format is not acceptable, they will not upload the data, or they won't care. They will not bother. And then it doesn't matter who can see the data because the data aren't there. So yes, I think that makes sense to me, is that we should encourage and make it easy and allow proprietary formats, so we have as many uploads and as a diverse data set as possible. And then if somebody comes along and says, look, I'm really unhappy with this, I can't read it, and then we work on that. So yeah, that could be left open in the recommendation document.
Yeah, I mean, we have to be a little careful about that, Yvonne, because some people are going to be like, okay, I shared my stuff, I used the format you told me to use, I published it in HydroShare, it's got a DOI, and now you want me to go back and change the format. So I would say we should try to avoid that situation if we can.
Oh, right.
But we may not know up front like what the best format is, and there's a format that everybody's using, and that's the one that we settle on. Like,
yeah,
okay.
Exactly. I see your point. Yeah, not change the format. So, I mean, one kind of IT thing, kind of as when I'm wearing my programmer hat, comes to mind is the concept of inheritance. And that is when you don't know how people will use what you're creating, you have to be very abstract. So I think our constant battle is kind of the abstract level and the implementation level. And we just can't anticipate all the usages and requirements. So we cannot specify them. So we have to do them from the abstract point of view. And first step is if you're using GPR data and you're using two systems that are out there, and I don't actually know what the other system is, but if you're using SNS system, well, please at least upload them in that binary format and the header that is in text format, and have a list of the processing steps you did. I think that's already huge. Okay, so and then people can use Python to at least see the GPR data and probably replicate processing steps. And that's pretty much it. Right? And then I think that works. And again, and seismic data aren't a problem because they've been around for a while, or issues. So that's all. They're open source tools. So almost we don't need to discuss the seismic data, right?
Yeah, Yvonne, I do have some thoughts about sharing scripts versus sharing processing steps. Like, I do think that sharing processing steps is an absolute minimum. Right. So as a best practice, that definitely should be written down. I do realize that with sharing scripts, it's more work, and there's the opportunity that those scripts become out of date.
Yeah.
But it is a record of the processing steps that were made. And I would have, like, if I accessed a data set 10 years down the road, and the specific software used may have changed or whatever, but if I had a script that was sort of like a record of the code that was run and the steps that were made, I'm more likely to be able to reuse that data than if I just have a list of steps or I don't have anything, right? So I would say I wouldn't put it out there that we don't want people to submit scripts, because I think if people have scripts, we should encourage them to submit them with the data as a record of what they actually did. But I sort of agree with you. It's not a hard and fast requirement. It's just that potentially makes your data more accessible and more potentially reusable down the road. I don't know. What do other people think about that?
Well, I'll chip in again. I agree. And one more reason to help your argument is, if I see an obsolete piece of code, it's not hard to translate it into something modern. When you don't have anything, then you have to do it from scratch, which is always hard.
Yeah, thank you for making
So,
that point, because that's the point that I was trying to make, and you made it much more
yeah,
eloquently than me.
yeah.
I mean, I've shared scripts. When I share data, I share the scripts that I use to process the data. MATLAB scripts.
Yeah.
And that shouldn't be hard for us because it's on our workflow, so there's no extra work needed. So yeah, I'm all for it. Yeah.
Sue, I had a question about the link that you sent us to this Jornada Piedmont seismic imaging data set. Is that one data set that's like the result of one sort of field survey or field event, or is this something that is changing over time or is being added to? I'm just kind of interested in granularity.
Yeah, so this is a requirement of this particular group. Part of their funding required that they publish their data with IRIS. And I think they're using IRIS's like kind of data back end to store it anyway, like just because it's so gigantic. I mean, it's just a humongous data set. So my understanding is this is the result of one field campaign that will be added to.
So how does that work with, sorry if I'm asking questions that you maybe don't know the answer to, but how does that work with the repository that I'm looking at here? Because I'm looking at, there's a citation, 2021 dryland critical zone Jornada Piedmont seismic imaging data set. The publisher is listed as International Federation of Digital Seismograph Networks, and then there's a DOI. And most people who are issuing DOIs really want the content that they're issuing that DOI for to be static and immutable, so it's not going to change. Maybe the International Federation of Digital Seismograph Networks doesn't treat their DOIs in that way, but I'm just curious about that.
To be honest, I don't really know. I know they're going to collect more data. They may have an additional DOI for it. This is what they have so far, but it's a requirement as soon as they collect it that they have to store it at a minimum, even if it's embargoed with these guys. And so I mean, this is their 2021 field season. I know that. I imagine if they have a different set, I mean, they're not going to need more seismic imaging, I would imagine, from the same location. That wouldn't make a ton of sense. So if they were going to get a second one, I imagine it would be from the playa. And so they probably have a separate DOI. I mean, that's an assumption. I don't actually know. I've just, in my conversations as a data manager with Marianne Carpless, I'm like, where are you publishing your data? She was like, we are required by our funding to do it here. And so as soon as I get it published there, I'll send you the link. And I'm like, great.
Yeah, fantastic. Please do.
Perfect.
That sort of hovers around this second to the last section in our best practice documents, though, which is organizing data for sharing. Because there's all these choices about which repository to use, what format to use, all of that kind of stuff. But the whole question of chunking is also a question. So do you chunk by location? Do you chunk by date? Do you chunk by location and date? Do you chunk by field survey or investigator, or all of those kinds of things? And those are questions, Yvonne, that you didn't cover much in your presentation, and I'm curious about those sorts of things too. Like what constitutes a data set that would be shared and published and that's sort of what I'm referring to when I say chunking. What's the thing that people share and publish?
It's site and line or transect. That's going to be for both GPR and seismic data. It's site and transect. It's all transects. Or if it's a grid, but let's pretend that's a bunch of transects. So I mean, seismic data can be collected also as a 3D data set, but that's pretty rare in academia. And in that sense, it's again just it's a site. And even more rarely so, it will be the time domain. So if you're passively listening, if you're trying to image, let's say, fraction networks, and you're passively listening without a source, you passively listen to noise, then there's a time component. So you can have your you can have your grid sitting there for weeks at a time, or separate time slices. Like a 4D data set that I like to call, but again, it's based on site. It's all about location and time, but rarely so.
Yeah, so Yvonne, I think under that section in this document, organizing data for sharing, it would be nice if we had a few recommendations about when you're in the field or before you go to the field, these are some planning steps that you may think about, because it's going to impact or affect the organization of the data that you produce, which is then going to affect the organization of the data that you share. And there may be some strategies for organizing by site, line, transect, grid, or time domain, and those all may come into play that maybe we should lay out. I realize that those may all be custom to a particular study, but acknowledging them as the sort of general organizing concepts, I think, would be good.
Okay, roger that. Yeah.
Okay, well, we're about 45 minutes in. Let me look at the other sections here. So we've got additional best practices for geophysical data. That's sort of the catch-all at the end, where we're like, okay, if it didn't fit in one of these other sections, but there's another best practice, we want to put it there. That's why that section exists. We've got formats for sharing geophysical data, which I haven't written anything yet, but there's a whole bunch of stuff about formats that I put in the first section because I just started furiously typing away notes there, Yvonne. So we need to move the format stuff out of repositories for sharing geophysical data down to formats. And then we haven't talked really in detail about the metadata for describing geophysical data. Most of what we've discussed so far is kind of focused around the data formats. But are the data files that are produced by these instruments and that you all are using and have talked about today, are they self-describing in a way that the metadata is inside the data files, or are there specific ways or accompanying files that you're using to describe these data?
Both, but I would not rely on the data files themselves. No. So yes, there is a need for human entered metadata, and yes, I really didn't talk much about that, and that's very important. I'll need to, I'll need to write that down in the section. Yeah, because one thing I failed in is because I'm so familiar with seismic data, it's hard for me to think as if I don't know anything about them, and how would I retrieve them and see them and deal with them. So I often go like, oh, well, that just, you just look at the header, or you just display, and it's right there in the fourth menu and fifth pull down. It's really not a big problem. It's not a big deal, right? So it's really, I have to say it's hard, but since my name is associated with the document, I need to do that. So that's going to be my homework.
Cool.
Okay.
Yeah, so I can see this, we need to move some of the notes and stuff around that are already in this document that we took today, but I see information starting to emerge that I think covers most of our sections here. And if we can just start fleshing those out, I think we've got a good start on this. And this document doesn't have to be produced in the next day. It just needs to get produced in the next, in enough time that people who are doing geophysical data collection know where to be sharing their data and all of that kind of stuff. So Yeah, do we have other questions for Yvonne while we've got him on the line? Now is your chance. I guess we've got just Sue left.
Yeah, I guess as far as questions go, I mean, we have metadata associated with each project, right? And so they're going to have in their methods, like when they go to publish, how all this stuff was processed. And then we have, you know, the auto-generated metadata, basically upon collection and things like that. It's kind of a reiteration of what we've already discussed, like what exactly do you want included on Quasi or wherever else this ends up getting published?
Yeah, so
right,
that's
you
a
know.
great question, Sue. And really it comes back to like what does your thematic cluster see as the sort of baseline data products that are being produced by your cluster that should be publicly available, shared, and available to the larger community of critical zone scientists? Because not all of that is going to be associated with a specific publication, right? So it's easy to identify data sets that are associated with a particular publication, and we definitely want those data sets to be showing up in a repository. And in a lot of cases, journal publishers are making you do that anyway, right? But there's all of these other baseline data sets that may or may not be associated with a specific publication that your thematic cluster group has to decide, okay, what are the products that our thematic cluster is going to be putting out there? How do we chunk them up into things that people can access in HydroShare and things that have their individual set of authors, titles, and citations, basically, that are going to get a digital object identifier when we publish them? And we can give you individual guidance if you have specific questions about specific things that you're doing, but I don't think there's a one blanket statement that I can give you that just covers everything, Sue. I think there's just too many types of data and too many things going on.
Like, I have a question though, like, so like outside of things like the tower data on Ameriflux and things like, you know, the seismic data on Iris and maybe open topography products and things like that. Like, what is your experience getting PIs to part with like long-term, rich, valuable data sets that don't have publications associated with them? Because I can't get them to part with those data sets.
It's really hard. You know, from a requirements perspective, you all have data management plans that were submitted with your proposals that should describe what you were going to do, and oftentimes those get commented on in the proposal review process, but they're rarely ever, you know, revisited to the point where NSF is like, we're holding you to what you said in your data management plan. And I mean, things also change over time. But this problem specifically that you're talking about, where people are collecting long-term data, it sometimes even transcends projects. Like Claire Welty has these chemistry data that she's been collecting in the Baltimore urban area for, you know, dozens of years now, that have probably been paid for by dozens of projects, and she doesn't have a definitive one publication source for all of those data.
We
and
have
so
that
you
here too. Like,
yeah,
you know,
yeah,
so like
I'm
there's
sure
like
you do.
there's a water quality data set over at Reynolds Creek that has been in existence for decades and decades and decades. But the ownership, I mean, it's fuzzy, right? So the USDA technically are the stewards of that data set, even though various researchers at BSU and ISU have worked on the data and have collected it, and, you know, sensors that CZO paid for have been, you know, added to it. And there's no way anyone is going to let me publish that data set. No way.
Well, you
I
know,
would
you know the
say-
expression that if you want somebody not to make any progress, just give them your data. So people should be giving data out more freely, just if nothing else, to give themselves time to finish it up.
The best I ever got with that is a metadata record directing them to the USDA's data manager.
That's great. And it's not uncommon. It's really not uncommon. I mean, there are hugely valuable data sets like this all over the country being collected by tons of people. And oftentimes those people retire and the data set goes with them, and it's never, the value is never realized because it just was never opened up and shared. So in terms of requirements, you all are on the line to meet the requirements of your data management plans and the terms and conditions of your cooperative agreement with NSF. I don't know what those terms and conditions actually say. I know what the ones in the hub say, but we're all operating under a cooperative agreement with NSF that has terms and conditions associated with them. And I think there probably will be coming a day when Richard Uritich says, please tell me about the data sets that you have shared from your thematic cluster. How many data sets, what types of data sets, where are they shared? And we're trying to get you set up with the data submission portal so you have easy access to get things submitted, but also have sort of the report that you can export that says, oh, well, here's the list of everything that we've shared. This, meets the terms and conditions of our cooperative agreement. But where to draw the line, Sue? Like, that is a hard question. And I would just say, do the absolute best that you can and be a staunch advocate for curation, because much of the value of data is in the curation of the data. Like, unless somebody creates that activation energy, number one, to get the data out there, and number two, to get the data described in a way that some reasonable human could actually use it, the data really have no value. As Yvonne said, the way to stymie progress is to give somebody your data without giving them any information about it. And then they're constantly on the phone with you saying, what are the units of column number 14? What instrument did you use to collect these data? What do the time units mean? Like you just can't answer those questions without a really intimate, the intimate knowledge that only those investigators have, that to get out requires that curation step, right?
I mean, I'm in complete agreement with everything you've said. It's just like, in practice, the way that you get someone to publish their data is to require it by the publication that they're getting.
Yep.
That's true.
There's two big sticks at the moment. One is the publishers wield a stick and say, we won't publish your paper until you've shared your data. The other big stick is the funding agency that says, you are under an agreement with terms and conditions that require that you share your data, and the definition of what should be shared is defined in your data management plan.
Right, and you can say that and threaten that and everything, but ultimately there has to be some sort of overview or some sort of being held accountable, and that's not going to come from a data manager.
No, it's not.
From a PI, or that's going to come from NSF. We're really not in a position to enforce that. We can say it again and again and again, and we can harass and we can bug. And I'm not like trying to like derail anyone, and I'm in complete agreement with everything that you're saying, and it adds tremendous value. It's critically important, to do all of these things that you're saying. But I'm just trying to like insert like a little voice of like the practical on the grounds. I cannot force somebody to publish their golden data set. I have no ability to censure them. I can't withhold their funding. I can't, give them a bad review on their annual review. Like, as a data manager, all I can do is show up and just say like, hey, these are what we're requiring you to do. So like, yeah, like I hear you, man, loud and clear, but the way that you get them to do it is by saying like, okay, in order to get this published, you have to have a DOI linking your data set. So you better publish your data set and I'll help you do it. That's honestly how you get them to do it.
Yeah, I think another way is, but takes time to build it, is peer pressure. So we start building this and it's useful, and more researchers come to it and submit their data. And then it's a part of the folklore. When they go get drinks, oh, this is the data. Where's the data? Can I see it? Wait, this thing you're talking to me about, and while we're eating this chicken parmesan, I'd like to just see it. Where's the map? Where's the location map? And like, well, I don't have it. And then, but that takes years to build. So I think that's a nice way of building things, but not a nice way always takes a long time.
Yeah, I'm
So
just trying to
Sue,
speak up on behalf of the data managers. Like, it's really not in our wheelhouse to force people to publish data. Like, we can't do it. All we can do is provide resources and assistance.
yep, I
That's it.
totally agree.
Yeah.
I understand and agree, and you know, we're clear on that. I think we're behind you. The stick is not going to be wielded by you. It's either going to be wielded by a publisher or it's going to be wielded by NSF. It's not even going to be wielded by us, because I'm a participant in the hub. I would love to see a humongous corpus of data coming out of the CZNet that we can facilitate access to through the hub, but I don't even wield that big of a stick. So one other thing that I will mention here, though, is Kirsten Leonard has been mentioning things that she's hearing from NSF about, you know, when you submit your annual report to NSF and you list publications in your annual report, you're actually required to upload those publications into NSF's document repository system. I don't actually know what it's called, or I can't remember what it's called, but you tell them about the publication, then you upload the publication so that there's actually public access to all of this stuff that you're producing on NSF funding. And she's saying that they're going in the direction of actually making data sets available in that same way. So data sets are public, or they are products of the research that you are doing with funding from NSF. You publish a data set or you make a data set available. You now need to tell NSF either where it's located in a reputable repository, or I don't know if they're actually going to create a repository and allow people to upload to their repository, or whether it's just going to be, just tell us what repository you put it in. But they're sort of going in that direction too, because NSF really wants these products of research to be out there and available, and they're trying to facilitate that.
Yeah, I mean, the first step again, it's on us. We need to do a good job here, and then we do peer pressure amongst ourselves. And if something's good, people will start using it. I have to say I'm also a little bit skeptical, because even if something's really, really good, having your own data set and not letting everybody sees it, it's even gooder. So it's hard to resist that, but yeah, like with any idea, and if it's really good, people will embrace it.
Okay, we're out of time for today. So next steps. We've got a bunch of notes from today in this document, Yvonne. I did not paste all of the notes in the right sections. Would you be willing to go and just take a look at the notes that I've taken for today? Maybe parse things out into the correct sections in the document, and then just start fleshing out the words around each one of those components. And then if there are areas of the document that we can help with, and by we I mean me, Shannon, Clara, we're totally willing to dive in and try and help with some of the words. But also, if there's elements of the document that you know Sue and the Drylands cluster are working on this, and the the urban cluster is also collecting similar data, can we start reaching out and having a little dialogue, either via Slack or email, or whatever you think is the best mechanism for that, to start having those discussions so that we can firm up the words that are in this best practice document and get it moving forward? Does that seem like a reasonable start?
Yes, I promise. And more details. I promise more details in the doc.
Okay.
So I'll just go with the GPR. I'll just take one file and see what I do with it, and then just write that, and that have that as a starting point. Okay.
Okay, Clara, anything else that I've forgotten? Looks like Sue dropped off, and so now we've just got Yvonne. But...
Yeah, I think that it's just us left. So I think that, thank you, Yvonne, that went really well. That was a lot of really great information. Thank you for having that presentation that was so thorough prepared.
Yeah,
You're most welcome.
thanks. Appreciate it.
You're
I
most
learned a
welcome.
lot today. Thank you.
Okay, you're most welcome, guys. Thank you.
All right. We'll be in touch.
Okay. Yep. Talk to you soon.
Bye-bye.
Bye.